Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing the hazard vulnerabilities. A disaster occurs when an extreme event exceeds a community's ability to cope with that particular event. Understanding the process by which natural disaster produce community impact is important for four reasons. Firstly, information from this process is needed to identify the pre-impact condition that makes community vulnerable to disaster impacts. Secondly, information about the disaster impact process can be used to identify specific segment of each community that will be affected disproportionately. Thirdly, information about the disaster impact process can be used to identify the event specific condition that determine the level of disaster impact. And fourthly, an understanding of disaster impact process allows planners to identify suitable emergency management interventions. There are also three event specific conditions: hazard event characteristic, improvised disaster response, and improvised disaster recovery. Two of the event specific condition, hazard event characteristic and improvised disaster response, combine with the pre-impact condition to produce a disaster's physical impact. The physical impact in turn combine with the improvised disaster recovery to produce the disaster's social impact. Communities can engage in three types of emergency management interventions to ameliorate disaster impacts. Physical impacts can be reduced by hazard mitigation practices and emergency preparedness practices, whereas social impact can be reduced by recovery preparedness practices. In this session, we are discussing the pre-impact condition in a disaster management system. The information from this process is needed to identify the pre-impact condition that make the communities vulnerable to disaster impact. For this, firstly, we have to analyze the hazard exposure. Hazard exposure arises from people's occupancy of geographical areas where they could be affected by specific type of events that threaten their lives and property. For natural hazards, this exposure is caused by living in geographical areas as specific as floodplains that sometimes extends only a few feet beyond the floodway, or as broad as the Great Plain of the Midwest where tornadoes can strike anywhere over an area of hundreds or thousands of square miles. For technological hazards, exposure can arise if people move into areas where they could be exposed to explosions or hazardous material releases. In principle, hazard exposure can be measured by the probability of occurrence of a given event magnitude, but these exceedance probabilities can be difficult to obtain for hazard about which the historical data are insufficient to reliably estimate the probability of very unusual events. Moreover, urbanization of the watershed caused the boundaries of 100-year floodplains to change in ways that may be difficult for local emergency managers to be anticipated. Even more difficult to estimate are the probabilities of events such as chemical and nuclear reactor accidents, for which data are limited because each facility is essentially unique. In such cases, techniques of probabilistic safety analysis are used to model these systems, attach probabilities to the failure of the system components, and synthesize probabilities of overall system failure by mathematical combination and probabilities of individual component failures. When we come to the physical vulnerability, the first thing to be discussed is the human vulnerability. Humans are vulnerable to environmental extremes of temperature, pressure, and chemical exposure that can cause death, injury, and illness. For any hazard agent like water, wind, ionizing radiation, toxic chemicals, infectious agents, there often is variable in the physiological response of the affected population. That is, given the same level of exposure, some people will die, others will be severely injured, still others slightly injured, and the rest will survive unscratchedly. Typically, the most susceptible to any environmental stressor will be very young, the very old, and those with weakened immune system. The second one is the agricultural vulnerability. Like human, agricultural plant and animals are also vulnerable to environmental extremes of temperature, pressure, chemical, radiation, and infectious agents. Like human, there are differences among individuals within each plant and animal population. However, agricultural vulnerability is more complex than human vulnerability because there is a greater number of species to be assessed, each of which has its own characteristic response to each environmental stressors. The third one is a structural vulnerability. Structural vulnerability arises when buildings are constructed using design and materials that are incapable of resisting extreme stresses like high wind, hydraulic pressure of water, and seismic shaking, or that allow hazardous materials to infiltrate into the building. The construction of most building is governed by the building code intended to protect the life safety of the building occupants from structural collapse, primarily from the dead load of the building materials themselves and the live load of the occupants and furnishings, but do not necessarily provide protection from the extreme wind, seismic, or hydraulic loads, nor do they provide an impermeable barrier in the infiltration of toxic air pollutants. When we come to the social vulnerability, the social vulnerability perspective represents an important extension of previous theories of hazard vulnerabilities. As a concept, social vulnerability has been defined in terms of people's capacity to anticipate, cope with, resist, and recover from the impacts of a natural hazard, whereas people's physical vulnerability refer to their susceptibility to biological changes. Their social vulnerability refers to their susceptibility to behavioral changes. The central point of the social vulnerability perspective is that just as people occupancy of hazard prone area and the physical vulnerability of the structure in which they live and work are not randomly distributed, neither in social vulnerability randomly distributed, either geographical or demographical. Thus, just as variation in structural vulnerability can increase or decrease the effect of hazard exposure or physical impact, so too can variation in social vulnerability. Social vulnerability varies across communities and also across households within communities. It is a variability in vulnerability that is likely to be of greater concern to local emergency managers because it requires that they identify the area within their community having population segment with the highest level of social vulnerability. So dear students, in this lecture we had discussed the pre-impact condition of a disaster or a hazard. That is, the information from this process is needed to identify the pre-impact conditions that make the community vulnerable to the disaster impacts. So my dear students, kindly go through this assignment question. The assignment question is, write in detail about first the hazard exposure, second one the physical vulnerability, and third one the social vulnerability. So dear students, in the upcoming lecture, we will discuss the event-specific condition in disaster management system. So see you soon. Until then, goodbye, thank you, and all the best.